In this video, we're going to talk about isolation. And no, not on an island and not all alone by yourself out in space. We're going to talk about isolating electrical circuits to try to find the problem. So I'm going to use a recent case to try to point out to you how to isolate components in a system to try to find the problem. When you have a carrier or a Bryant communicating system, you have to start with a communicating indoor unit, either a gas furnace or a fan coil. Then you'll have the user interface that communicates with the fan coil or furnace. Then you may have an outdoor unit that is communicating with the system. In this case, we had a zone system with a zone board and a smart sensor in a second zone, and then of course your damper controls. The system was not communicating. When they would try to have the user interface find all the components, sometimes it would find the indoor unit and sometimes it would find some other components, but the communication was very sparse. And so we had to figure out what was causing the lack of communication on this system. We get many phone calls in tech support from techs out in the field who either have a short or have a component in a system that's not operating or the unit itself will not come on. Many technicians in the field get a headache by just looking at wiring diagrams like this. Isolation is the only way that you can narrow it down to try to find out what your problem is. Even fairly simple wiring diagrams like this from a variable speed furnace can cause issues. And again, the only way to track down a short or a loose connection or a component that's not working correctly is to isolate the circuits and try to find what circuit is causing the problem. The very first thing you want to do if you're on a communicating system is to check the software in the thermostat. With all the changes in equipment and the different models that we have currently, you have to make sure that the thermostat is up to date on the software so that it will communicate with the outdoor unit and the indoor unit. To start to find out the software version, click on the menu to go to the menu on the user interface. So when you tap the menu, you will go to the first page of the menu. You want to go down to the second page of the menu where the service hat is. Just tap the service hat to go to the next page. By tapping the hat, it should take you to this screen, which gives you the model and serial numbers of all the equipment and controls that are connected to this system. Tap on the system control to find the software version of the user interface. That will bring you to this screen, which lists the model number of the thermostat, the serial number of the thermostat, and the software version of the thermostat. This particular thermostat software version is 04.47. At the time of this recording, the current software is 4.56. Make sure that your thermostat is upgraded to the latest software so that we are sure that it will communicate with the equipment that you are installing. So as we stated previously, the first thing you want to do is make sure that you have a communicating indoor furnace or fan coil. For a communicating system, the indoor equipment must be a communicating type equipment. Once that is established, then you want to check your wiring between the indoor unit and the user interface to make sure that the ABCD connection is landed in the proper place and your connections are tight. Another thing you want to make sure of is that you do not run the user interface wiring anywhere near power wiring, as in this example where they put the thermostat directly above a light switch. This can cause induced voltage on the thermostat wiring and can cause communication failures. If you still cannot establish communication between the user interface and the gas furnace or air handler, one of the tricks that we do is to take the user interface and go to the furnace or fan coil and connect it with a short piece of thermostat wire. If it finds the furnace or the fan coil on this short piece of thermostat wire, then you know that you have a problem in the wiring between the thermostat and the fan coil or furnace. If it still doesn't find the furnace or the fan coil with this short piece of wire, then there's either something wrong with the software, the user interface, or the furnace or fan coil control board. The next thing we want to check is the connection to the outdoor unit. There should be 2 or 3 wires going to most of the communicating units that Carrier and Bryant uses currently. You will have a green connection, a yellow connection, and sometimes the white wire from the outdoor unit is connected to eliminate a communication problem. So make sure that your green, yellow, and white wires are wired correctly from the outdoor unit to the indoor. So in the particular case that we're looking at in this video, we have a zone system. So the user interface is zone 1 and it's connected to the ABCD connections. The gas furnace is connected to ABCD. The outdoor unit is connected by the green and yellow wires to ABC. The smart sensor in zone 2 is connected to ABCD. And the damper controls are connected on the left-hand side of the board where the control for the dampers goes. When using a zone control board, the 2 ABCD connectors at the top of the zone control board are in parallel with each other. With the indoor, outdoor user interface and a smart sensor all connecting here, it can get pretty congested. Make sure that all your wires are making good connections on these points. So continuing our process of isolation, at this point we are going to isolate the zone system from the rest of the equipment. To do this, we'll take the ABCD connection from the user interface and land it directly on the furnace or fan coil control board. We will also take the green and the yellow wire from the outdoor unit and land it directly on the terminal strip on the fan coil or the furnace. If we communicate with this type of connection, then we know that our problem is in our zone system. So in the job that we're looking at, we did communicate with the user interface connected directly to the furnace and with the outdoor unit connected directly to the furnace. So we know that the problem is in the zone system. So now what we want to do is reconnect the user interface to the ABCD connection on the zone control board, the green and yellow to the A and B connection on the zone board, and the furnace back into the ABCD connection. At this point, we are going to leave the dampers and the smart sensor disconnected to see if we communicate. So in our last step, we found that we did still have communication. So now we are going to reconnect the dampers onto the zone control board to see if there's a problem with the wiring or the dampers themselves. We are leaving the smart sensor disconnected. So by connecting the dampers into the zone system, we found that we still communicated. So then we connected the smart sensor back into the system. And as soon as we connected the smart sensor back into the system, we had intermittent communication. So we have determined that the smart sensor is where the problem is. So the problem all the time was the remote smart sensor incorrectly wired into the zone board, causing the communication issue. By isolating the different components of this system, we were able to find the problem and get the system communicating as it should. Remember this diagram at the beginning of the video? You can also troubleshoot a diagram or a system like this by isolation. One of the first things you should do is get rid of the economizer. This will take a complete control system out of the picture. By using the bypass plug, which you should keep when you install an economizer, you can plug the bypass plug in, which will totally bypass the economizer. So if there is a short or a problem in the economizer or the economizer wiring, this is a quick and easy way to find that out. You can also isolate the gas heat board from the system in case there is a short or a problem in the gas heat section. On the main board, you have fire controls, fire dampers and fire alarms, which can also keep the system from operating. The main board is simply a connection point. So usually by changing the main board usually does not get you anywhere unless the traces on the back of the main board become cracked or broken and lose connection. So next time you have a larger system like this where you have to troubleshoot an electrical issue, try the isolation process to try to find out where the problem is. The same process can be used on a gas furnace board. You can isolate all the components that plug into the board and eliminate them one by one. You can also isolate the plugs that go into the blower motor and the ICM motor or the inducer motor. And by isolating various circuits, you can usually find out where the issue is. So whenever you're blowing fuses or the circuit's not working or there's some kind of electrical issue, always try to isolate the circuits so that you can get the circuit that is causing the problem by itself so you can fix the issue.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.